Hello and welcome to another series of AWS Learning. Today I'm looking at AWS Transit Gateway. By Transit Gateway, it's like a gateway. You can connect Amazon VPCs together, with Amazon accounts, on-premise networks, all of them to a single gateway, right? And then when your network grows, and then when you have a complex network, then Transit Gateway can help you to make it simpler to understand, troubleshoot, and to design. You have a better visibility and control over your resources, and then it improves security. And you can, in terms of administrative workloads, then you have a less workload whenever you use Transit Gateway. So maybe this is the reason. If you look at the left side, so originally without Transit Gateway, you have several VPCs, and then each of these VPCs, imagine we are looking to use VPC peering. And then for these VPCs, some of them, they need some kind of gateways, like maybe VPN gateway, any kind of virtual gateway, internet gateway. And then it makes, we have here only 4 VPCs, but if we have 10, then you can imagine how complex will be that architecture. But when you move to the right architecture, which is using AWS Transit Gateway, then you see that, oh, it's now much simpler to understand. It's less complex. At the same time, in terms of using gateways, as you see here, we have only one direct connect, right? And it can be used by all VPCs. We have here one VPN connection. These services are scalable, so they can be used by all VPCs, and they can accommodate all traffics, right? That is going in and out. So for all these reasons, we like to use Transit Gateway. And for today, I'm going to work on a very simple idea, and the idea is here. I'm looking to create and actually attach 2 VPCs to a single Transit Gateway, and then just to know how traffic goes from one VPC to another one, I'm going to do a simple ping test from one instance in one VPC on to the other. So instance 1 in VPC 1 has SSH enabled, has public IP address, and then first we go by SSH to this instance, and then we ping instance 2 in second VPC. And then if ping works, then it means that from the networking side we are fine, and we could use Transit Gateway. So let's try it. Let's try it on AWS. So I will come back to this architecture once in a while, but my suggestion for you is to grab a screenshot from this screen, and then work with me to create the network. So now I'm going to create VPCs, and then the subnets, and then instances in each subnet, and I will come back here to show you what's the next step. So in terms of VPCs, let's go to VPC services. So I do not have that 192 here, so let's create that VPC. I'm going to say this is my 192.168.0.0/16. This is my IP block, and then that's it. This is my VPC1. Actually 192 will be my VPC1. It's good to go over all names to have an idea of what's going on, and then to maybe identify the services and components. So this is actually my VPC2. I need to change the name. So I have VPC1 192.168.0.0 and VPC2 in 10 IP block. Now I need to have one subnet here, I need to have a public subnet here, and then one private subnet here, right? In a /24 and the first like subnet. So let's do that. Let's go to subnets. Let's create in VPC1, let's create my public subnet 1, and then no preference for availability zone, and then that will be 192.168.0.0/24, and create. And then let's go back to the subnet. I believe I have that 10.0.0/24, so I just need to change the name here to private subnet 1. So I have those two subnets. And then let me make the P capital. Sometimes I'm really like picky on the names. So, but we know that this public subnet, I just wrote public subnet, but we are not sure if that is really public or not. To be sure that that is really public subnet, we should associate it to a route that has internet gateway. So let's see, this is for VPC1. Let's go to route tables. VPC1, this should be this one. This is VPC1, so it's the main route table for VPC. No, sorry, it's not the VPC1. There is not any route for VPC1 because it's a new one. So we can create one. So it's good to create one for that VPC. But it's really interesting because for that VPC we should have okay, I refresh it. Yeah, we should have like one main route table, because whenever you create a VPC, it should be a main route table, at least one created by default. And the reason is that they have that internal communication, local communication there, right? So to make that subnet public, first we need internet gateway. So let's go to create internet gateway. This is internet gateway, create it. This is my VPC 1 internet gateway, and then done. Then let's attach it to my VPC1. So when you see VPC1 only is here, means the other VPCs, they have already attached an internet gateway. And then let's come back to route table. I'm coming back to the main. This is VPC1. This is the main route table. Let's go to main route table, edit. So I said that whatever goes to internet traffic should goes through internet gateway and the recent internet gateway, and then save change. Now we know that to make subnet public, we should associate that subnet here. This is a main route table, so by default all subnets should be associated to this route table right now. And if not, you can go to edit subnet associate. You can check whatever subnet you like to associate to any route, and you can say save. So while I've added here, but you don't need it because it's a main route table, and by default public subnet 1 is associated right now. But to make it like much more clear and like to emphasize the concept, I've added here. Now by doing this, in this step, public subnet 1 is really a public subnet. So we leave the private one private, we don't care about it. And now let's create our instances. Let's go to EC2 services. Let's go to launch. So this is my instance 1, and it's Amazon Linux machine, T2 micro fruit treater eligible, because on instance 1 I need to have SSH connection. So I need to have first keeper, so whatever you have already, or you can create a new one. And also you need to have public IP version 4, public IP address version 4 for that. So let's go to the network. So it's in VPC 1, public subnet 1, IP version 4 is public, IP version 4 is enabled. In terms of security group, we only need SSH to this instance. So SSH from anywhere is available, accessible, allowed. So let's launch. For the second instance, let's go to create instance 2. So instance 2 is in this private subnet, so that is like we don't need any public IP address, no SSH, nothing. So instance 2 is a Linux machine again, T2 macro, no keeper, proceed without the keeper for the VPC. Let's go to VPC 2 this time, and it's in private subnet. I don't need any private public IP address. In terms of security group, I only need ICMP because I like to have a ping communication. So let's go with all ICMP, all like handshake, all signals from anywhere for now, and then let's launch it. Okay. So while I'm waiting for instances to be up, let's come back to our plan. So right now VPCs are there, subnets are there, instances are there. Now let's go to the transit gateway itself. Let's go to VPC part. If you go down all the way here, you can see transit gateway. So let's go and create our first transit gateway. This is my transit gateway, and we don't need anything, just create. We should wait for transit gateway to be available. I make a pause and I'm waiting for this one to be available, and then I go to the next step. Okay, now it's available, and when transit gateway is available, then it's time to go again and go to transit gateway attachments. Now what I need to attach those VPCs, right? So I will attach these VPCs to my transit gateway. So which transit gateway? My transit gateway, I'm attaching VPC type. So I'm attaching VPC 1 here, and this is the subnet that I have in VPC 1, right? So we can just go, because this is done in AWS Academy, so it said that this feature is not available, and I'm okay with that. So let's create another transit gateway attachment. So this time I'm going to attach VPC 2, right? So let's go to create. So again, now I could attach 2 VPCs to my transit gateway, and I should wait for them to be available here, right? So let's wait. While we are waiting for these 2 to be available, let's come back to our plan. Now imagine that by doing that attachment, in terms of transit gateway we are good, but we should now think about these route tables. These route tables are remained. We didn't work on these route tables, and the reason is that whenever traffic goes to internet, right, from this VPC has internet gateway right now here. So whatever traffic goes to internet goes through internet gateway by the route that we define in route table. But we should define a route in route table to say, now whenever traffic goes from this VPC to any IP address in another VPC, right, that traffic should go through transit gateway to any other destination, right? And vice versa. Any traffic goes from this destination to VPC 1 destination, it should go through transit gateway. So let's define these 2 first. So let's go to route tables. Let's go to VPC 1 main route table here. Let's edit it. Now We say that internet traffic goes to internet gateway, and now let's say whatever traffic goes to the other VPC, which is this IP block, goes to transit gateway. Where is transit gateway? Is here, and my transit gateway, right? So I have now three rules: local one, internet one, transit gateway one, safe. And which subnet is associated? Public subnet one, right? Now let's come back to routes. For the other VPC, the other VPC is VPC2. This is the main route table. Let's go to do something same. I said whatever goes to the other VPC, VPC1 from this VPC, it should goes to transit gateway and my transit gateway, safe. And to be sure that actually this is again a main route table, I don't need to explicitly associate subnets. Just to practice, I will add my private subnet here to have an effect of these rules, right? So private subnet is here. Now it seems this tunnel, the transit gateway tunnel through route tables is fine. Instances, let's check instances and transit gateway, and then let's do a check. Let's come back to transit gateway. So transit gateway is available, good. Let's go to transit gateway. Let's go to the associate to this gateway. So I have two VPCs already associated, which is good. In terms of propagation, we have two VPCs, they are propagating the information, and then I have two routes between these two, right? So this is good. This is in terms of transit gateway, we are fine. Let's go to the instances. Let's see. Yeah, those instances are running, everything is fine. So instance 1 has public IP address, instance 2 doesn't have any public IP address, so it's in a private subnet. Let's go to instance 1. Let's go to connect. Let's connect to instance 1 by SSH, and let's go to grab instance 2 private IP address to do the ping. So I can now ping private IP address of instance 2, and wow, so it's now working. So ping works. It means, let's stop it. It means this SSH connection to instance 1 works, and I could from instance 1 CLI, I could ping instance 2. So it means that traffic goes through transit gateway and I'm fine. The only thing is that I'm not fine with it is in instance 2, right, in security group. If I go to the security group, if I go to edit, I said ICMP is allowed from all IP addresses, right, which I don't really like it. So let's do something. Let's go and make a restriction here, make it much more secure. First reason, I like to say only ICMP packets are allowed from my instance 1. And to do that, let's go to instance 1. Let's grab its private IP address. Let's come back to instance, so we can delete this one. We can say now all ICMP packets are allowed to only this IP address, and to say only this IP address, we should say /32, right? So I said ICMP traffic is only allowed from instance 1 and safe. Now let's see if still I have, so still ping works, right? So it means that that rule works fine, and by doing that I could make everything happens here. At the same time I could restrict ping communication to only instance 1, right, to make it more secure. Okay, so I hope you enjoyed this one and you could practice working on your transit gateway. Thank you.